A keyboard is divided into sections called octaves. Every octave has the same 12 notes. We name the white notes using 7 letters, C, D, E, F, G, A, and B, but we name the black notes according to their positions relative to the white notes. For example, the black note that lies just above or to the right of the note C is called C sharp. This note can also be called D flat, indicating that it lies just below or to the left of the note D. But in fact, there is no difference between black and white notes. We can see this by looking at other instruments that play the same notes as those on the keyboard, but do not distinguish these notes from each other by color. So, if there's no difference between black and white notes, why do we use this sharp-flat naming system? Why not just name the 12 notes with 12 different letters? To understand this, we need to go back 4,000 years to Mesopotamia. The Mesopotamians knew the 12 notes that make up the circle of fifths, but they didn't give these notes names. But like us, they did select 7 notes from the circle of fifths to create a scale, and their scale is the direct ancestor of the major scale we use today. The Mesopotamians didn't even name the 7 notes of their scale. Instead, they named the intervals heard between pairs of these 7 notes. For example, as described on tablet UET 774, they called the interval between the 4th note and the 1st note of the scale nidkablum, and the interval between the 1st and 5th notes was called nisturum, the one between the 5th and 2nd notes kablitum, the one between the 2nd and 6th notes isartum, the one between the 6th and 3rd notes kitumum, and the one between the 3rd and 7th notes embubum. Notice the sequence of numbers generated: 4152637. These 6 intervals are all fifths because every note in a clockwise direction on the circle of fifths is the 5th of the note before it. And this is what a fifth sounds like. For example, it's the interval between the 1st and 5th notes of the major scale. To learn more about the circle of fifths, watch the video The Origin of the Circle of Fifths, available at musiccircle.net and on the Music Circle YouTube channel. Notice that the 2 notes that make up the last interval, pitum, the interval between the 7th and 4th notes, have a different spatial relationship on the circle of fifths. They are not beside each other as fifths are, but across the circle from each other. This interval also has a different audio relationship. Today, we call this interval a tritone. In any major scale, 6 of these 7 intervals are always fifths, and 1 is always a tritone. This fact is what the Mesopotamian musical system is based on. If you want to learn more, read the Mesopotamian musical system page, available in the Music Archaeology drop-down menu at musiccircle.net. During the 1st millennium BC, the Mesopotamian 7-note scale made its way to Greece, and later it was adopted by the Romans. By the 6th century AD, the Roman statesman Boethius was representing the 7 notes of the scale with letters from the Latin alphabet. Today, we continue this tradition, naming the white notes of the keyboard with 7 letters. It is interesting to note that knowledge of the circle of fifths is documented in China as early as the 3rd century BC, and that the Chinese named the 12 notes with 12 different names. Evidence suggests that Chinese knowledge of the circle of fifths was transmitted from the Near East sometime during the 1st millennium BC. To learn more, read the paper A Mesopotamian Origin for the Ancient Musical and Musico-Cosmological Systems of the West and China by myself, Sarah DeRose, and available on the Mesopotamian Musical System page at musiccircle.net. Knowledge of the circle of fifths, however, did not make its way to Greece and Rome. Instead, the first known reference to the circle of fifths other than in Mesopotamia and China is found around 1670 in a book by the Ukrainian composer Diletsky. Around the time of Diletsky, the signs for sharp and flat began to be used in Europe to indicate notes that were slightly altered in pitch. By the 19th century, our modern sharp-flat naming system was in place. To summarize, the very beginnings of the tradition of naming the notes using 7 letters can be traced back 4,000 years to the Mesopotamian naming of 7 intervals. But when we began to name all 12 notes, a problem arose, because you can't name 12 notes with only 7 letters. That's why we need sharp and flat symbols to create more note names. But there is another, deeper reason underlying the sharp-flat naming system. It was created so that every scale contains all 7 letters. Why? Because as far back as ancient Mesopotamia, 7 was considered a magical number. Here's how the sharp-flat naming system does this. First, recall that there are 7 names that are just letters. These are called natural names. Then, each of these letters is combined with a sharp symbol to create 7 sharp names. Then, each of these letters is combined with a flat symbol to create 7 flat names. This makes a total of 21 names, and these names are distributed among the 12 notes in such a way as to allow every scale to contain every letter. For example, here we construct the scale of F major by placing whole 1 over F. Now, we name the first note of the scale F. But notice that the letter F also appears in whole 7. Because every letter must appear only once in every scale, we must call the note in whole 7 E, not F flat. The notes in holes 2, 6, and 3 have only one naming option, G, D, and A. Now, because the letter A was already used in hole 3, the note in hole 4 must be called B flat. Finally, the note in hole 5 must be called C because the letter B was already used in hole 4. That's why we name the notes in the scale of F major F, G, A, B flat, C, D, and E, so that all 7 letters are represented. As we saw in the video Music Circle intro, there's an easy way to summarize the sharp-flat naming system by adding an outer rim to the circle of fifths that's divided into 4 sections. Then we add a pointer extending from hole 1. And as the pointer rotates on the outer rim, it indicates how to name the notes in a particular scale. Here, for example, the pointer indicates that when naming the notes in the scale of C major, natural names are used. In other words, sharp names and flat names are not used. Therefore, the notes in the scale of C major are C, D, E, F, G, A, and B. Notice that all 7 letters are represented. Now, let's construct the scale of G major by putting G in hole 1. In this position, the pointer indicates the section naturals, then sharps. So, in this scale, natural names are used whenever possible. If this is not possible, sharp names are used. Therefore, the notes in the scale of G major are G, A, B, C, D, E, and F sharp. Once again, all 7 letters are represented. When the pointer lands on the section sharps, then naturals, or flats, then naturals, there are 3 possible positions. Notice that in each of these positions, the notes in all 7 holes have 2 different names. Consequently, each of these 3 scales can be named in 2 different ways. For example, the scale shown here can be named by giving priority to sharp names over natural names, or it can be named by giving priority to flat names over natural names. In the first case, the scale is called F sharp major and contains the notes F sharp, G sharp, A sharp, B, C sharp, D sharp, and E sharp. In the second case, the scale is called G flat major and contains the notes G flat, A flat, B flat, C flat, D flat, E flat, and F. Notice that in both cases, all 7 letters are used. To learn more about how the sequence 415-2637 can help you understand music theory, watch the videos The Dominant Seventh Chord and How to Change the Key of a Song. To learn how this sequence was used in ancient cosmology, watch the video The Musical Origin of the 7-Day Week. These videos are available at musiccircle.net and on the Music Circle YouTube channel. Thanks for watching.